Swayam Prabha. Digital India. Educated India.
One simple example. First, we will identify variables for a system, and then we will try to draw a causal diagram for this one. Hypothesis of dynamics in urban region. The job availability attracts migrants to the city. New arrivals to city expand the labor population. Population absorbs available jobs, decreasing job availability. In the long run, as labor also creates demand for additional services and facilities, the further increase the number of jobs in the city comes about. More jobs increases job availability. It's a pretty simple and kind of an example written in a more straightforward language. So, using this we can identify one causal link per statement. So, that is what it's about. So, we have job availability attracts migrants to the cities. So, job availability should influence migrants or migration into the city in migration, and as migrations occur, that expands the labor population within the city. So, second statement. So, first statement, the variables are job availability increases migrants, and more jobs are job availability is there, more migrants are into the city. As more migrants are, as migration happens, migrants are going to expand the labor population within the city. As population, the entire this thing labor, as this labor population absorbs the existing jobs, decreases job availability. So, population is going to take up jobs, and jobs will decrease job availability. In the long run, labor also creates demand for additional services. As more labor comes, new shops open, new services has to be offered. So, that will after long term increase the number of job availabilities within the city. So, we will identify this. Let us take it CLD example 1. So, we can identify some variables called as say job availability, migration, labor population and jobs. These are 4 variables we identified. Using this, let us create our kind of first causal loop. So, let us create the links, I guess. So, let us take the job availability, we say affects our migration. The first statement said job availability attracts migrants to the city. So, job availability is more, migration is going to be more, that is what we can intuitively expect. So, job availability affects migration. So, these left side are the initial variables we identified, and migration expands the labor population within the city. So, migration increases the labor population. As labor population is more, what can you expect? The job availability has to come down because they are absorbing the new jobs. Decreases job availability. Of course, as more jobs come, there is more job availability And there is one more statement there which had the same variable had 2 links. Other one was the labor population after some time increases jobs within the system. So, to indicate the after some time part, we can simply put a D on the link to indicate that there is some delay in the process. After some time, the labor population increases the jobs within the system. So, these are initial set of causal links that we have created based on the description, but this again is still very cumbersome to read. We can just combine all of them, we do not need to repeat all the variables so many times and create what we call as a nice causal map of it. We are continuing the same example. Let us start with job availability. You can call it in-migration also. We are not talking about people leaving, people coming in. You can make it more explicit. Then we have labor population. Then we have jobs. These are unique variables that we have. Job availability increases, in-migration increases. In-migration is more. You can expect increase in labor population. Thus, labor population absorbs the jobs. A decrease in general job availability has to happen, but after some time the labor population increases the number of jobs, but after some time, so there is a delay, and as jobs increases, of course, job availability also tends to increase. So, just to indicate it, this D indicates delay. So, this is a nice diagram we have. This captures the same description that we had in English, but it is much more easier to read and much more compact. So, the idea is not to just make the diagram, but also have our discussions revolved around that. Suppose we say, okay, as job availability is more, you can expect the in-migration to increase. That in turn is going to increase our labor population. That is going to absorb the jobs. As labor population increases, that is going to decrease the number of jobs available. So, as jobs decreases, you can expect migration also to slow down. The migration rate, as migration rate slows down, the labor population increase, that also slows down, right, and it is going to come to some sort of a balance in the system. So, this loop will again be a balancing loop. This loop is again a balancing loop. So, in this model, as you can see, there are 2 loops. They start with job availability, in-migration, labor population, jobs and job availability. There is an outer loop and there is an inner loop. So, inner loop is negative feedback. Let us look at outer loop. As job availability is more, in-migration increases. As they increase, labor population increases. As labor population increases, jobs increase. That increases again job availability. So, there is a positive feedback also that is happening in the same direction, strengthening the phenomenon. So, we have one reinforcing loop or a positive feedback loop. This is a balancing loop or a negative feedback loop. Again, the term positive, negatives are all placeholders. Negative does not mean bad, positive does not mean good. This reinforcing or balancing or positive or negative. Throughout the course, you will find that it is very easy to explain the concepts. In fact, that is it, that is the entire thing about causal loop diagram. I am done. The difficulty comes in when you start practicing it and start trying to, say for example, read newspapers and try to come up with a causal map of what is actually happening to understand dynamics. Now, that becomes challenging. There are some certain guidelines for this causal loop diagram which I will discuss. Let me move on to some of those guidelines for the causal loop diagram. So, this about description itself is called as a reference mode. So, many times we can use this causal loop diagram, this kind of mapping to actually understand what the problem is. Many of us want to become analysts, right. So, this kind of systems thinking tool will really help you make a good analyst or a systems analyst, rather than focusing on the domain of the subject. You can actually become system analyst. But these kind of causal diagram can help understand and link the various variables and help understand the problem. So, this itself can help discover what the actual problem is that we are trying to solve. Okay. So, we already seen this, the loop polarity, links we saw, and loops also we saw, balancing loop and reinforcing is going by reinforcing it. When loop feedback loop response opposes the original perturbation, the loop is negative or goal seeking. When feedback loop response reinforces the original perturbation, the loop is positive or reinforcing. So, negative loop or goal seeking loop or a balancing loop, the same, and reinforcing or positive feedback loop are the same. Okay. So, one way to understand that is suppose we have links like this. So, for example, x1 affects x2 affects x3, which again affects x1, right. And if you want to do it the right way, then what we need to do is split it. Let us call it x1 say dash. Let us see how x1 affects x2 and how x2 affects x3, and in turn how x3 affects x1. Right. So, meaning we kind of cut one of the variable and say, okay, let us initially allow x1 to increase, and as x1 changes, how does it affect x2, x2 changes, how does it affect x3, and again as x3 changes, how do you affect x1. Ensure that you again come back and see what is happening to the variable x1 which you perturbed initially. And if the original direction of x1 dash and x double dash is the same, then we say that it is a reinforcing loop or a positive feedback loop. If it is the opposite direction, as we initially perturbed this by increasing it, but then eventually x1 double dash seems to decrease here, then it becomes a goal seeking loop or a negative feedback loop. We are not interested in the quantum of increase. We are not interested in quantum of increase, we are only looking at the direction. It may be that even the positive or negative, the direction is very tiny, but still we are only interested in that for now. When we move to simulation, put numbers, then we will worry about actually how the system is behaving. We will come to that. But right now we can only worry about the direction of movement. Like for example, the job availability attracted huge number of migrants, but maybe their job creation is very low. The new jobs that they add to the system, it can be there. Just because labor population high doesn't mean that similar number of jobs has to be created. But the direction is the same. The number of some additional jobs happen. That's what we are trying to say. So which, okay, I'm here. Yeah. So even in this, so one other shortcut to figure out whether it's positive or negative feedback loop is simply count the number of positive or negative signs within a loop. So, the number of negative signs is odd, then it is a positive feedback loop. So, here if you see plus and there is one minus sign, so there is odd number of minus signs, so it must be a negative feedback loop. Even in this example, I can do one more. So, let us say x, y, z, w, x. So, here suppose I have minus, plus, as x increases. So, there are two negative feedbacks. So, x increases, y decreases. As y decreases, z also decreases, same direction. As z decreases, w increases. As w increases, x again increases. So, it is in the same direction finally, the variable x. So, short way is there is two negative feedbacks. or a even number of negative feedbacks of negative links, then it is a positive feedback system. If it's odd, as x increases, y decreases, as y decreases, z again increases, as z increases, again w decreases, as w decrease, x also decreases. So, eventually x went down when you originally started with x increasing. So, the shorter way is you can see there is odd number of negative links, that means it must be a negative feedback loop. So, we have two loops here, loop job availability, in-migration, labor population, job availability, this is a loop. The second case, job availability, in-migration, labor population, jobs, job availability. So, that is the loop. So, and all are in positive direction, that case you do not have any problem. If it's all are positive, it has to be a positive feedback system. The only problem comes in when there is one negative link, then what happens? Then count the number of negative links. If it is even, then it must become a positive feedback. If it is odd number of negative links we have, then must be a positive feedback. And as I told, there are all these small tips that we can give, but then we will we'll go through them and then we'll do a lot of examples. Yeah, so the number of negative links in a loop is even, the loop is reinforcing. Number of negative links in loop is odd, the loop is balancing.